A recent study indicates lasting changes to hunger neurons in the brain following fasting. Tune in for more only here on the People Scientist podcast. You are listening to the People Scientist, the podcast dedicated to helping us optimize our health with the latest scientific findings on neuroscience, physiology, and nutrition. I, your host, Dr. Stephanie Caligiuri, a nutritionist, physiologist, and neuroscientist, will be here with you every single week, bringing us information to ignite our thinking, to help us be one step closer to the healthiest we can be. Hello, my People Scientist Army, and welcome back to the People Scientist podcast for episode 148, where I aim to arm us with some scientific information so that we can all become a little bit smarter and a little bit healthier with every new episode. How are you doing today? I hope that you're doing well, and thank you for letting me be a part of your day today. But before I jump into today's topic, I want to give a special shout out to a handful of very special listeners who have recently bought me a coffee to say thank you for the show. So thank you to Joshua, Alex, Jayon, Kieran, and Tony. Your support means so much to me. It often feels funny doing a podcast as I post an episode out to the ether and hope that the episode makes a positive impact on someone. So it always means a lot to me when any of you message me, leave a comment, or buy me a coffee to let me know that the show impacted you in a positive way. So thank you so much to all of you for your kind words and for your support. So what are we going to talk about today? Well, it was my turn in the lab to pick a recent study to discuss in Journal Club, and I came across a study that will be published in May this year in the journal Cell Metabolism by Grzelka and others. The study is entitled A Synaptic Amplifier of Hunger for Regaining Body Weight in the Hypothalamus. This study aims to understand the neurobiology behind why so often we might regain weight after weight loss. So before we jump into the core takeaways on that topic, as we always do, let's start off with a foregone fact where I share a scientific finding from long ago. Cannon and Washburn back in 1912 in the American Journal of Physiology talked about the difference between hunger and appetite. So what do you think? Is there a difference between hunger and appetite? Well, the scientists here in this paper speculate that yes, there is, because we want to eat when we are not hungry. And because of that, we desire delicious food even when we feel physically full. And this suggests that appetite is independent of and distinct from hunger. Appetite also has important psychological elements. It involves craving. And I think we can all appreciate that candy, for example, is not very fulfilling of hunger, but it can taste good and it can make us happy. Hunger, on the other hand, they described back in 1912 as a dull ache or gnawing sensation in the stomach. It is the organism's first strong demand for calories, and when not satisfied, this feeling is likely to grow into an uncomfortable pang. Now, hunger may exist separate from appetite, as for example, when hunger forces the eating of food that does not taste good. We think of the context years ago when individuals would be hunting and gathering, and they likely had to eat food to survive to suffice their feelings of hunger that they did not necessarily want to eat because it did not necessarily taste good. Intriguingly, the feeling of hunger can subside the longer one fasts, and why the feeling of hunger subsides with longer fasting is not completely understood, but it is thought to be related to reducing energy expenditure from hunger signals when we clearly are in a calorie deficit. And have you ever been ill with a fever? Let's say you had the flu or a respiratory infection, and did you notice that you didn't feel much hunger or appetite? Even though you haven't eaten as much as usual, one would think that we would feel hungry. Again, this is an argument that hunger and appetite are a lot more complex than simply a simple response to a lack of food. As such, this began the discussion that hunger originates in our brain as a result of many complex interworkings. And if we fast forward to today, over 100 years later, we are still uncovering how the brain perceives and signals hunger. So let's dive into that and jump into the core takeaways of today's topic and how we can use this neuroscience to our advantage. It is feasible for us to lose weight by reducing calorie intake and increasing energy expenditure through exercise. However, a difficult component to weight loss is maintaining that weight loss. Weight regain is quite common and can contribute to distress and poor self-image. In today's episode, I talk of recent studies looking at how fasting can change hunger circuits within the hypothalamus of the brain to strengthen feelings of hunger, to increase food intake, and to cause body weight regain. I use the analogy of a flashlight. Now think of a flashlight now instead of having one battery powering it. Fasting makes it as though there are now 2 to 3 batteries powering that flashlight, making the light even stronger. In this study, the scientists suggest that fasting may make the hunger circuits even more strong, more powerful, and moreover that this is a lasting effect, leading to long-term overeating and weight regain. Now, not everyone experiences this effect from fasting or restriction. We have yet to appreciate who responds this way and who does not. But I think understanding our neurobiology and how our choices might impact our brain and our behavior can be very empowering. In this episode, I provide a couple of neuroscience-based strategies on how to potentially prevent this rebound in hunger. Now, let's get into those scientific details. Weiss in the American Journal of Preventive Medicine in 2007 investigated how many people regain weight after weight loss and what characteristics were associated with this. So they recruited 1,310 men and women who reported at least a 10% body weight loss. So let's put that into perspective. For example, let's say someone weighs 200 pounds. They would have to lose at least 20 pounds to be included in the study. Then the scientists followed up with them in regard to their body weight. The scientists defined weight regain as after that weight loss, gaining at least 5% of their body weight back. So in the scenario of an individual initially weighing 200 pounds, if they lost 20 pounds and regained 10 pounds, that was considered someone who lost a significant amount of weight and also who regained a significant amount of weight. Now, there are limitations to these definitions. For example, what if someone simply put on muscle weight from weightlifting or regained water weight, particularly if they had followed a low carbohydrate or ketogenic diet, as water weight regain is anticipated after going off of that type of diet. The reason why water weight regain is anticipated is because our body stores carbohydrates as glycogen, which holds on to a lot of water. So when we reduce calories, and particularly reduce carbohydrates, our glycogen stores are used up for energy, and we lose water weight with that. Upon replenishment of our glycogen stores, we will also put on water weight. So please do not be disheartened or demotivated when noticing a bit of weight regain after resuming a diet with our maintenance amount of calories, as water weight regain is to be expected when our glycogen stores are replenished. Nevertheless, based on these definitions in this study, what % of people do you think had significant weight regain after weight loss? The scientists reported that approximately 33% of people reported that they regained significant weight after weight loss. So 1/3 of the people. I initially thought that that number might be higher. But the study looked into what characteristics were associated with this group of 33% that had regained their weight. They had noted that being a woman was strongly associated with weight regain. If the individuals identified as female, 38% of them reported weight regain versus 29% of men. The more weight someone lost, also the more likely they were to regain weight afterward as well. Individuals who lost 15% or more of their body weight were more likely to report weight regain. If the individuals were sedentary and had more screen time, for example, they used their phone, their computer, or they watched TV for more than 2 hours per day, they were unfortunately more likely to exhibit weight regain. So this raises the question, why are women more likely to have weight regain after weight loss? I think the sedentary component makes sense somewhat, but why the female gender? I personally believe it has to do with the brain circuit that I'm going to talk about right now. And not enough research has been conducted on gender or sex differences in eating behavior, in disordered eating, and in weight loss. And this is something that I personally plan to study in my own lab this year. If you remember back in episode 145, I spoke a bit about bulimia nervosa. I think that bulimia nervosa is far more common than we realize. The DSM-5 is a set of criteria we use to diagnose different psychiatric illnesses and conditions, and the criteria for bulimia nervosa includes if individuals go through periods of restriction, such as fasting or calorie restriction, followed by periods of uncontrolled eating, where they would eat more than the average person would in a 2-hour time window. Now, based on that criteria and based on the increased popularity of intermittent fasting, I believe bulimia nervosa is far more common than we realize. And right now, as it stands, it's far more common in women. Now, during periods of fasting, our brain is adapting to the lack of calorie intake, and this may result in stronger hunger signals and a lack of control when eating. So let's get into that recent publication as to what exactly might be happening in the brain during this time. In the journal Cell Metabolism this month, Grzelka investigated the specific neurons and connections involved in hunger and weight regain after fasting. The scientists aimed to assess the effects of fasting, but it was just one bout of fasting, which I find intriguing because I personally think in us, in humans, it is the repeated bouts of restriction and binging that results in the worsening of disordered eating symptoms. Nevertheless, the study I think can still be insightful to understand how one time of fasting can change the brain. So to assess the effects of fasting, the scientists had the mice fast overnight for 16 hours. Which for a mouse with a high metabolic rate is quite a significant fast that can result in the mice losing around 10% of their body weight. So in reality, this 16-hour fast in mice mimics a much longer fast in humans. In this publication, the scientists had another group that was fasted and then allowed to have free access to food in the morning to investigate short-term binging following the fast. They also had a group of mice fasted and given free access to food for 6 days to replicate a longer-term refeeding scenario. Now, the control groups were mice that were given free access to food 24/7, and another group of mice given daily access to food with a 25% calorie reduction in order to mimic an individual that might be in a calorie deficit every day. Then the scientists studied the activity and strength of connections in the hypothalamus of the brain known to regulate the feelings of hunger. They had noted that one bout of fasting and weight loss in the mice resulted in more excitatory activity input into the agouti-related protein expressing neurons of the arcuate nucleus of the hypothalamus. So let me give an analogy to help explain that. Let's say that we have a battery that is powering a flashlight. Let's say with fasting, it is now equivalent to as though there are 2 to 3 batteries powering the flashlight, resulting in the flashlight being even brighter. A similar thing happened here in the brain of the mice fasting. The hunger neurons were receiving more electrical input and therefore firing more frequently, more brightly, so to speak. Next, the scientists wanted to understand the extra batteries in this analogy. What was causing the extra power input into those hunger neurons? Well, it appeared to be a particular group of neurons in the paraventricular hypothalamus that expressed thiotropium-releasing hormone. If the scientists silenced these neurons, if they removed the extra battery, so to speak, then the mice did not binge as significantly and did not regain as much weight after the fast. Next, the scientists observed that this circuit continued to be strong even after the refeeding of 7 days post-fast. So in other words, the flashlight continued to have 2 to 3 batteries giving more power input into the flashlight. This effect persisted. So it is not as though this effect of fasting dissolves as soon as one eats after a fast. It appears that this strengthened hunger circuit persists for several days thereafter. Next, the scientists wanted to get a little more specific and wanted to understand the components of these extra batteries. They wanted to understand the specific receptors that regulated the enhanced glutamatergic input into the agouti-related protein neurons. This was when they realized that it was the NMDA receptors that were responsible for this strengthened hunger circuit. So again, if I bring it back to our analogy of the flashlight, it is as though the scientists realized it is specifically, let's say, a special type of battery, like a solar-powered battery that was responsible for being added onto the flashlight that is making the flashlight brighter. The scientists realized if they activated this hunger circuit, it resulted in persistent weight regain after the fast. So what the scientists here have been able to characterize is that a fast in mice does indeed result in some lasting changes to a circuit in the brain that increases the intake of food and increases weight gain. The question is, can we translate this to humans? Perhaps we can. Let's see if I can pull something from the clinical data. There's a really great study that was published in the Journal of Physiological Reports by Carem in 2020. They had conducted an fMRI study in individuals who were asked to eat a high-calorie diet for 10 days and to also fast for 10 days. The scientists then looked at the recruitment of different brain regions when the participants were shown images of high and low-calorie food. So a little more detail on the diets the participants were given. Let me get into that. The 10 days of high-calorie intake included a high-fat and high-carbohydrate diet and tended to cause the participants to gain 7 to 10% of body weight in 10 days. So the scientists really wanted to see essentially what effect a binge would have on their brain activity. Then there was a washout period in between the fasting period. During the fasting period, the participants were to fast for 10 days, which is quite a long fast, but they had free access to water and an electrolyte solution. During this study, the participants were all monitored 24/7 in a clinic setting. So this study was very well controlled. It is a very well designed study. So the participants at the final day of the high calorie period and 1 day of eating after the fasting period were shown images of low and high calorie food and had their brain activity imaged using functional magnetic resonance imaging. So what do you think the scientists noted? During the high-calorie period and during weight gain, recruitment of that brain region, the hypothalamus, in response to food cues was reduced. During the fasting period, many different things were noted. There was increased recruitment of the hypothalamus, that brain region where the hunger neurons were greatly activated in the mouse study we just talked about. The scientists also noted greater recruitment of brain regions involved in taste and pleasure. At the same time, they noted a reduced recruitment of a brain region involved in impulse control and inhibitory control, the dorsolateral prefrontal cortex. So what does this tell us? What this human brain imaging study tells us is that a prolonged fast seems to cause changes to how the brain reacts to images of food. Fasting causes enhanced recruitment of hunger, pleasure, and taste brain regions, and it reduces the recruitment of impulse control. This, as a result, can lead to an individual having a binge episode, losing control, and eating far more than they normally would. This human imaging study supports the mouse study in that fasting can change how the brain encodes for food desire. So what does this all boil down to? I think what these studies indicate to us is that fasting and restriction might predispose us to enhanced hunger cues, to binge episodes, and therefore to weight regain. This, in part, I believe, can explain the neurobiology of bulimia nervosa and binge eating. If we find that we are losing control with our eating behavior, perhaps we can consider if we restrict ourselves. Do we fast for prolonged periods? And if we do that, if that is the case, then perhaps avoiding fasting protocols may help us feel more in control of our eating and less likely for weight regain. What I am so curious about is if there is a strategy of weight loss that does not significantly strengthen this hunger circuit, because this strengthened hunger circuit seems to lead to binging and weight regain. Well, back in episode 125, I speak about the science of intuitive eating. Intuitive eating is meant for us to listen to our internal hunger cues, to be more interoceptive, and avoiding significant restriction. Turns out that in these studies, when individuals eat more intuitively without significant restriction and instead listen to their own hunger signals, many benefits were noted for mental health, greater self-esteem, better self-image, and a feeling of having greater control over eating behavior. So if intuitive eating interests you, perhaps go back and listen to episode 125. As well, all the way back in episode 63, I speak about heat therapy as a way to target the hypothalamus. So in this episode, I talk about how specific neurons in the hypothalamus regulate our hunger. And part of the reason why we have a fever, when we have a fever, that our appetite, our hunger, and our food intake is reduced, is because of the role of our hypothalamus in also regulating our body temperature. So the same brain region that regulates our hunger also regulates our body temperature. As such, there are observational studies indicating that heat may reduce food intake. So it could be theorized that heat, like a warm shower, sauna, a warm bath, can recruit our hypothalamus to regulate our body temperature and as well changing our feelings of hunger. So if that episode interests you, then feel free to go back and give episode 63 a listen. And if there's any data that comes out on how to prevent the strengthening of this hunger circuit to help us maintain a healthy body weight, to prevent binge episodes, to prevent weight regain, then you bet that I will make sure to update all of you. So that is a wrap, my people scientist army. The latest updates on how fasting and weight loss can change the circuitry of the brain. In a mouse study, scientists indicate that a 16-hour fast can strengthen the excitatory input onto hunger neurons in the hypothalamus. The scientists conducted many in-depth experiments to realize that these highly activated neurons lead to increased food intake and significant weight regain. Moreover, what's important is that these strengthened inputs onto the hunger neurons is lasting. Even 7 days after refeeding from a fast, the scientists noted that these hunger neurons were still firing much higher than they normally would. And as a result, this can lead to persistent overeating. Can this finding in the mouse study be corroborated in humans? Well, there is some scientific evidence using functional magnetic resonance imaging that a long fast in humans can cause the hypothalamus of the brain, as well as regions involved in taste and pleasure, to be more active in response to images of food, and that there seems to be less recruitment of brain regions involved in impulse control. This can help explain the neurobiology as to why when we might restrict ourselves, we are more likely to feel like we've lost control over eating, might have a binge episode, and therefore can explain the weight regain and perhaps even the neurobiology of bulimia nervosa. So the take-home message: if we are finding a lack of control over our eating, if we experience binge eating, realizing that fasting may contribute to this, I think is a very powerful piece of information. I think understanding our own neurobiology can be very empowering in helping us understand why we feel the way we do. So thank you for tuning in, my people scientist army. I hope that this episode was insightful and useful for you. If you want to follow me on social media to get more tidbits of information, my handles are in the description box to this show. If you want to buy me a coffee to say thank you for the episode, you can do so via the links in the description box too. I hope you all have a wonderful 2 weeks, and I look forward to meeting you back here in 2 weeks' time. Bye for now. I am a scientist simply sharing scientific evidence. Some of the clinical interventions I discuss are not appropriate for everyone. Before making any changes to your diet or lifestyle, please do consult the advice of your physician or dietitian. My opinions expressed here do not necessarily reflect those of Mount Sinai Hospital and its affiliates.